this collection of videos, we are going to do a brief review of trigonometry as we head into calculus. Now, in terms of trigonometry, it all starts with triangles. Everything we're going to do in trigonometry is motivated from that origin. So over here in our visual, we've got a triangle with side lengths little a, little b, and little c, and angles capital A, capital B, and capital C. When we talk about a trigonometric measure on an angle of the triangle, in this example, I've chosen the angle capital A, that's going to be some sort of ratio of the side lengths of the triangle, where what we're calling a side length of the triangle is in reference to this angle. So for example, we can take a look at the sine of the angle A. That's going to be the ratio of variables little a and little c, or more generally, the side that's opposite the angle A divided by the hypotenuse length of the triangle. And because there are three different side lengths of the triangle, we have three different options for what could be going in the numerator of this ratio, and then two remaining options for what could be going in the denominator of this ratio, and that gives us a total of 6 different ratios of side lengths of the triangle that we could look at, and that's why we end up with 6 different trigonometric functions listed over here on the right. The sine of the angle, the cosine of the angle, the tangent of the angle, the cosecant of the angle, the secant of the angle, and the cotangent of the angle. While there are 6 different trigonometric functions, something that's really nice is that we can actually think of all of them in terms of just the sine of the angle A and the cosine of the angle A. And that's because, just based on the way fractions work, we can define the 4 remaining trigonometric functions in terms of the sine and the cosine of the angle in the following ways. The tangent of the angle is equal to the sine of the angle divided by the cosine of the angle, something you could determine by taking a over c and dividing it by b over c. The c's will end up canceling, and you'll end up with a over b, which is the tangent of the angle. A very similar calculation shows that the cotangent of the angle is equal to the cosine of the angle divided by the sine of the angle. And over here, as you look at that definition of the cosecant of the angle and the secant of the angle, you'll see that what you have is just the reciprocals of the sine and the cosine, although very frustratingly, the reciprocal of the sine is the cosecant, while the reciprocal of the cosine is the secant. And so this is our first foray into trigonometric identities that help us define 4 of those trigonometric functions in terms of just the sine and the cosine of the angle. Now, because we're focusing so heavily on the sine of an angle and the cosine of an angle, and those trigonometric functions were measured by looking at side lengths divided by the length of the hypotenuse, it becomes really convenient to make the length of the hypotenuse in the triangle 1, so that we no longer have any ratios to consider when we're just dividing by 1, and we'll just be looking at an adjacent side and an opposite side to that angle. So over here on the right, we've demonstrated that. If we have a unit circle, meaning that the distance from the origin over here to this point right here is 1, then the cosine of this angle that we've now called theta would be the length of the adjacent side divided by the length of the hypotenuse, which is cosine of theta over 1, or just plain cosine of theta. So this distance, the x-coordinate of the point, is equal to the cosine of this angle measured theta, and similarly, the y-coordinate of this point is equal to the sine of that angle theta, as it's the length of the opposite side of that triangle. And so all these coordinate pairs that you see going around this unit circle over on the left are giving you the cosine of the corresponding angle and the sine of that corresponding angle. And you'll see that you have measurements in both degrees and in radians. In a calculus class, it's fairly standard to work almost exclusively in radians. Now, the unit circle is something that you could memorize. I'm not big on recommending memorization, so I would just say have a good reference and make sure you can look up the values of the sine and the cosine of an angle if ever you need it. Now, definitely not something to memorize, but something to be aware of are the Cartesian graphs of our 6 different trigonometric functions, Cartesian just being a fancy word for their graphs in the xy plane. And while it's not the main subject of this video, there are plenty of really nice animations that you can find out there on this lovely website, YouTube, that demonstrate how you can obtain these Cartesian graphs from the information that's present in the unit circle. So for example, if you take a look at your unit circle over here, and you think about the sine function, which is the y-coordinate of this point, we're going to start here with our theta value equal to 0 and our y-coordinate equal to 0. And you can see that our y value is rising as our theta moves counterclockwise. And so you can see that this pink graph that's being created here is showing the rise in that sine value as our theta value is moving counterclockwise. And you can continue this process until our theta value reaches an angle of 90 degrees or pi over 2, and that's when our sine function reaches its highest height, which is going to be a height of 1. And after that point, you can see that our sine function is going to start decreasing until it hits 0 again when our angle is at a full measure of pi, which you can now see in this Cartesian graph. And as we continue to travel in this direction, our y-coordinate becomes negative until it reaches its minimum value when this full angle as measured counterclockwise from the positive x-axis becomes 3 pi over 2 before we start seeing an increase in those negative values again, returning back to a y value of 0 after we've made a full rotation. And so you see that basic shape of the sine curve here, and then you can see that as we just continue to circle around, this pattern that we're seeing with the sine curve from 0 to 2 pi is going to continue. And the fact that this curve repeats every 2 pi units is called the period of the graph. This is a periodic graph that repeats after an interval of 2 pi. So in addition to the Cartesian graphs that you have visualized here, you also have this information about the period of the graph, which is just indicating how often that graph repeats its basic structure. Now, if necessary, we can talk in great detail about inverse trigonometric functions at a later time, but I just want to introduce the notion of an inverse trigonometric function. And that starts with thinking about what we're doing when we're considering trigonometric functions. Whenever we have a trigonometric function, we're thinking about being given an angle theta, and then what the trigonometric function gives back is either the x or the y coordinate, depending on if you're thinking about the cosine or the sine of the angle theta, respectively. So we're given an angle, and a trigonometric function outputs an x or a y coordinate. What an inverse trigonometric function does is it reverses the input and the output. So instead of being given an angle and outputting either an x or a y coordinate, we're going to be thinking about with inverse trig being given an x or a y coordinate. And what we're going to output is the angle theta that has that x or y coordinate in the curve. For example, if we were given an x coordinate of 1/2, we would draw a vertical line here at x is equal to 1/2, and we would see where that intersects our circle. Right here, we've got pi over 3, and we would say that the inverse cosine, or the arc cosine, as some prefer to say, of the number 1/2 is the angle pi over 3, since that's the angle that corresponds to the triangle I've drawn in this first quadrant here with an x coordinate, or a cosine value, of 1/2. That's a very short reminder of what an inverse trigonometric function does, is it just reverses the input and the output. So with trig, you're given an angle and you output either an x or y coordinate. With inverse trig, you're given an x or a y coordinate and your output becomes an angle. Your inverse cosine function thinks about being given x coordinates, and your inverse sine function thinks about being given y coordinates. Now, the last of the very basic things that I would like to cover is the notion of trigonometric identities. And the problem that we have here is that there are a lot of them. There are so many that it's basically impossible to list them all out, and it becomes incredibly overwhelming to look at things like what I have on the screen right now. What I would advise is creating your own trig cheat sheet instead of using things that you can find pre-made and filling it only with the trigonometric identities and facts that you seem to use frequently, or things that seem to be helpful to you. There's way too much on this sheet for us to even think about using, but for the rest of these videos, I'm going to use just a couple of facts. The first I'm going to use is something I'm going to call a Pythagorean identity. You'll see it over here. And it's this idea coming from the unit circle that the sine squared of an angle plus the cosine squared of an angle is equal to 1. The second thing that I'm going to use on this sheet is a sum and distance formula. They're not super common. I would have to look them up, quite honestly, if I knew I needed to use one, but that's why I'm directing your attention to them right here and right now. So again, make your own cheat sheet. Don't be afraid to look things up. Don't try and memorize too much of this trigonometric stuff, but do try to have the things that you use frequently in one place so you don't have to scour the internet looking for just the right thing you need.